Hello everyone, welcome to our YouTube channel Sweat Talks. Our topic is interprocessing communication message passing. I am Grishma and my partner is Divya under the guidance of Dr. Prasad, PhD Swek Bhimavaram. Introduction. Interprocess communication is a fundamental concept and operating system that allows the process to exchange the data and synchronize their action. In this presentation, we'll explore the different techniques of IPC using message passing. Message passing methods. Now we'll start our discussion on the communication between the process through message passing. In this method, the process communication with each other without using any kind of shared memory. If two processes P1 and P2 want to communicate with each other, the procedure as follows. Establish a communication link. If a link already exists, no need to establish it again. Start exchanging the messages using basic primitives. We need at least two primitives: send message or send destination, receive message to the host or receive message. The message size can be of a fixed size or a variable size. If it is a fixed size, it is easy for a OS designer but complicated for a OS program. And if it is of a variable size, then it is easy for the programmer but complicated for the OS designer. A standard message can be of two parts, header and body. The header part is used for storing messages, type, destination ID, source ID, message length, and control information. The control information contain information like what to do if it is runs out of buffer space, sequence number, priority. Generally, message is sent using FIFO style. Here is a diagram for message passing. The diagram represents that sending process message passing module, and after that the process ID and a message passing module and a receiver process. Message passing through communication link. A link has some capacity that determines the number of messages that can reside it temporarily, for which every link has a queue associated with it, which can be a zero capacity or a bounded capacity or unbounded capacity. In zero capacity, the sender waits until the receiver informs the sender that it is a received message. In non-zero capacity cases, a process do not know whether a message has been received or not. After the send operation, for this send operation, which receiver explicitly implementation of link depends upon the situation. It can be either a direct communication link or an indirect communication link. Direct communication links are implemented with the processes use specific process identifier for the communication, but it is hard to identify the sender ahead of a time. For example, the print server indirect communication is done through shared mailbox, which consists of a queue of messages. The sender keeps the messages in the mailbox and receives the picking them up. Message passing through exchange the messages, synchronization and asynchronization of message passing. A process that is blocked is one of that it is waiting for some events such as resource becoming available or complications of input-output operations. IPCE is possible between the processes of some computers as well as processes running on different computers, that is, in networked or disturbed system. In both the cases, the process may or may not be blocked while sending a message or attempting the process. So, message passing may be blocked or non-blocked. Blocking is considered as synchronization, and blocking send means the sender will be blocked until the message is received by the receiver.
Similarly, blocking receive has the receiver block until a message is available. Non-blocking is considered asynchronous. and non-blocking sender sends the message and continue. Similarly, non-blocking receives has the receiver receives a valid message or null message. After a careful analysis, we can come to the conclusion that for the sender it is more natural to be non-blocking after message passing, as there may be a need to send the messages to different processes. However, the sender expects acknowledgement from the receiver in case the sender fails. Similarly, it is more natural for a receiver to be blocking after issuing the receives, as the information from the received message may be used for further execution. At the same time, if the message sent keep on failing, the receiver will have to wait indefinitely. That is why we also consider the other possibilities of message passing. There are basically three preferred combinations: blocking send and blocking receive, non-blocking send and non-blocking receive, non-blocking send and blocking receive. In direct message passing, the process which want to communicate must explicitly name the recipient or sender of the communication. Example: send P1, comma message means send the message to P1. Similarly, receive P2 message means to receive the message from P2. In this method of communication, the communication link gets established automatically, which can be either unidirectional or bidirectional. But one link can be used between one pair of sender and receiver, and one pair of sender and receiver should not possess more than one pair of link. Symmetric and asymmetric between sending and receiving can also be implemented. That is, either both processes will name each other for sending and receiving the messages, or only the sender will name the receiver for sending the message. And there is no need for receiver for naming the sender for receiving the message. The problem with this method of communication is that if the name of one process changes, this method will not work. Indirect message passing. Processes use mailboxes for sending and receiving messages. Each mailbox has a unique ID, and processes can communicate only if they share a mailbox. Link established only if a process share a common mailbox, and a single link can be associated with many processes. Each pair of processes can share several communication links, and these links may be unidirectional or bidirectional. Suppose two processes want to communicate through indirect message passing. The required operation are: create a mailbox, use this mailbox for sending and receiving messages, then destroy the mailbox. The standard primitive used are: send a comma message, which means send the message to mailbox A. The primitive for receiving the message also works in the same way. Received a comma message, which means receives the message to mailbox A. There is a problem with this mailbox implementation. Suppose there are more than two processes sharing the same mailbox, and suppose the process P1 sends a message to the mailbox. Which process will be the receiver? This can be solved by the either enforcing that only two processes can share a single mailbox, or enforcing that only one process is allowed to execute the receives at a given time, or select any process randomly and notify sender about the receiver. A mailbox can be made private to single sender receiver pair, and can also be shared between multiple sender receiver pair. What is an implement of such a mailbox that can have multiple senders and single receiver. It is used in client server application. The port is owned by receiving process and created by operating system on the request of receiver process and can be destroyed either on request of the same receiver process when the receiver terminates itself, enforcing that only one process is allowed to execute. The receive can be done using the concept of mutual exclusion. Mutex mailbox is created which is shared by n process. The sender is non-blocking and send the message. The first process which executes the receives will enter in critical section and all other processes will be blocked and will wait. Now let's discuss the producer consumer problem using the message passing concept. The producer places item in the mailbox and the consumer can consume an item when at least one message present in the mailbox. The code is given below: producer code and consumer code. In producer code, the producer places item in the mailbox and consumer code. The consumer can consume an item when at least one message present in the mailbox. Now coming to conclusion, recap of inter-process communication using message passing. Inter-process communication through message passing provides a reliable and efficient of communication between processes, enhancing system performance and stability. Importance of proper inter-process communication techniques. Understanding and implementing appropriate inter-process communication techniques is crucial for the successful development and operations of operating system.